Okay, welcome back. We're in the middle of page 5 of our statistics class notes. We're starting section 1.4, collecting data to understand causality. So studying causality, well, first of all, what do I mean by causality? The question, when somebody says they're studying causality, they're trying to figure out if one variable causes another to happen. For example, does cell phone use cause cancer? For instance. That can be understood in terms of two different kinds of variables. So when you're studying causality, you want to look at a treatment variable, which means whether or not a specific treatment is used, and then the outcome or the response. Sometimes people just call it the response outcome variable. And that's whether or not a certain outcome is seen. The goal here is to determine if the treatment variable causes a change in the outcome variable. So for example here, example 8, if you want to know whether a test prep book improves test scores, you would record if the book was used to study for the test, that would be the treatment variable. So whether or not, yes or no, was the book used to study for the test? And then what were the results of the test scores? So all the different results of the test scores would be your outcome variable. Okay, treatment and control group. A treatment group is the group of your data, your data set, the group that receives the treatment or has the characteristic of interest of whatever we're talking about. The control group is the group that does not receive the treatment. Okay, so back in this example, not everyone would use the test book because you wouldn't, the test prep book, or you wouldn't be able to see if it was actually the test prep book that improved the scores or not. So you need some people to use the test prep book, that would be the treatment group, and some that would not use the test prep book, that would be the control group. Okay. A placebo is like a harmless pill if we're talking about a medical study or a look-alike, given in place of actual treatment. And the placebo effect is reacting to a treatment after being told you are receiving the treatment when in fact you are not. So this is often done in medical studies, and somebody, if they're studying a new cancer drug, somebody might just get a sugar pill. Unfortunately, they're not getting the new drug, but they don't know that. That's called blinding. We'll talk about that in a little bit. But and some will not get the sugar pill. They'll actually get the actual pill that's supposed to help them with the cancer. Okay. All right, so what are some good practices in studying causality? One, we need to have a controlled experiment, which means researchers assign subjects to a treatment group, and that can show causality. Just the fact you have a controlled experiment can show causality. Now, if you do random assignment, if you get randomly assigning subjects to the treatment group, and we often use technology for that because humans do not do a good job of randomly assigning on their own. This often will balance out differences in the groups to minimize bias. Okay, and we'll talk much more about bias later. There's stuff I need you to know about bias, but bias just means something that's tending to sway the study that is not meant to sway the study. Okay, if we're trying to test for a cancer drug, we want to know whether that cancer drug is working or there's something else going on that's biasing the process. Okay. Blinding means that an independent party assigns subjects to treatment group. Double blinding means that neither the researchers nor people getting the treatment, etc., nobody knows. Researchers do not know who's in the treatment group. The treatment group often doesn't know, but also researchers don't know in double blinding.